should be started. So, yeah, I guess a special video presentation. Just because these people are just so fucking obnoxious. And what the hell they do with the video? There it is. Alright, so this Ian Gostling guy, Gostling, I think I'm saying that right. Well, anyway, Ian. Whatever. Doesn't matter. Okay, he's made a video, and it's just a typical. So he sent me an email requesting that I unblock him, and he's this obnoxious troll who can't paraphrase anything I say accurately or correctly. I mean, I did a video explicitly diagramming all this. I've hundreds of times, literally hundreds of times, talked about the 1-3-5 Galilean ratio in gravity. That it's twice the time, twice the weight, twice the velocity, and you people say it's 4 times the energy. I mean, I've been over it so many times. And he makes this patronizing, obnoxious piece of shit video as if there's something here that I've missed that's, in this video, and there isn't. And he overtly is making statements, again, that are debunking conventional physics' laws. And yet he feels no inclination that he should be telling everybody, look, isn't it amazing? Conventional physics has been wrong all this time. There is no conservation of momentum law. Yeah, amazing. Well, anyway, it's just so bad, and so it just illustrates that this is why humans can't do anything, is because these noisemakers get in the way, fuck everything up, and nothing rational can ever be accomplished because they just make something simple complicated. Or they make it unseeable because there's so much mud on the lens. Because these slobs get in the way and just dirty up every subject they can. It's just terrible. Yeah, such a blight.
Hello again. Just before I move on to something about spring condition.
Okay, can't hear him. I can't hear him. So I don't know if you can, but I can't.
I just wanted to finish off this. Gary's theory, Gary's momentum energy.
This is not even a theory, frankly. It's so fucking obvious. 9 pounds is 9 pounds is 9 pounds is 9 pounds. Okay? If you're going to move 9 pounds, it takes a certain amount of energy to move 9 pounds. 9 pounds moves the same way no matter where the 9 pounds is, blah, 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 blah. The theory is not anything very dramatic. Yeah, I mean, I've been over the lever thing so many times, but yeah, I mean, if you insist, and then you can explain, like I said, I've asked them for 2 years to draw a lever and explain how it works, and they won't do it. They just refuse. So he'll do all these things. He'll do all these antics, okay, but he won't do the simple thing I'm doing all the time, which is explaining why I believe a certain thing. Because I don't have any choice. There's no options here. So you keep talking about this magical inertia issue. Well, there's no theoretical way it can exist. And you have to deal with that argument. You can't just keep saying it as if you demonstrated somewhere that, yes, there really is an inertia thing and it functions differently. It looks a little too glary. See what we can do. Probably is better, but we'll find out. Alright, so the simple argument I have made over and over and over again. So the lever will oscillate perfectly with a 2 mass here and a 1 mass out here. Okay, you put energy in, oscillates perfectly. Obviously this is going twice the velocity that this goes, okay? This goes just that velocity, this goes that velocity, okay? Twice the velocity. Can't help it, can't stop it, that's what it's going to do, and it'll keep oscillating, demonstrating that it doesn't have an imbalance in the energy. So the longer it oscillates, that's sort of an indication that it's very constructive, okay, and that there is no destructive counter, no struggle, no lopsidedness. Alright, and the simple argument is whatever this mass weighs at this location, this, as far as the lever is concerned, weighs exactly the same. And that if you could, you put a 2 mass here All right, and you just switch these two, and you press over here. Whatever this weighs the same thing. And pressing over here, you could not possibly tell the difference because they both have to follow the same path. The stick has to follow the same path. To give this twice the velocity and this one velocity, it has to follow the same path in space over a period of time. Can't possibly have the proportional and correct velocities if it doesn't travel exactly the same spatial locations. It has to move exactly the same. There's really no choice. Alright, so he's done some jerky experiment where he ties a spring to a stick. Okay, it's on not a full lever. Puts a one mass and then a two mass here and a one mass here. Now we have no indication they actually measured or weighed these things properly. We don't know if they're actually in the center because he's using the center. He's not hanging them. So if you hang them, you don't have to worry about whether it hangs this far or whether it hangs this far. It just doesn't make any difference. But if you have them in the plane of the lever, it does matter whether they're a little bit off or not. Okay, because that changes their weight in actual fact. But I mean, the principle is the same. Okay, I mean, you're on this end, you're pushing on one location. You really don't have a choice. If this weighs 9 pounds, this will have to weigh 9 pounds. And you can't change its weight. You can't change what it weighs to the spring. And it has to move through the same space because of the fact that it's that weight on the spring, and the spring's going to move a certain speed here, and this speed is going to be the same for this object or this object. The spring will move the same speed. So you can't change that if you have these weight ratios proper. If you have a proper 2-to-1 relationship, you cannot change, okay, its function. It has to do it, or there isn't conservation of momentum, and there's not conservation of energy. So it has to do it. So they're showing this little difference in oscillation time, and they're saying, well, because they've proven this difference in oscillation time, they've not only broken the law of conservation of momentum, because they're not going to explain where the momentum went, and they've broken the logic that these things weigh the same. That this side of the lever really can't tell the difference. They're just weights on the stick. Alright, so I've been over and over and over this, and I'm just pleading with them, just draw this. Draw this and explain how you understand it differently. How something else happens on the lever. That when it's oscillating perfectly with the 2 mass here and the 1 mass here, okay, and that I stop it all of a sudden, and I let this fly off, that it won't be going twice the velocity. And that when I stop it and let this fly off, it won't be going 1/2 of that velocity. Just explain how that's the truth. That this somehow is only going 1.4. Just explain how that's possible. And then you'll have an argument to make. But why should I be convinced when you can't explain it? You really do have to explain, okay, something. You can't just throw your little cardboard and duct tape together piece of crap in front of somebody and say, see, I've made, a talking horse. Whatever. It's just bullshit. Alright, so this is his old experiment he's holding in front of him. It's this little proud trophy.
Theory says that.
So we have really he has never established that he has these things in the right distance from the fulcrum, the weights, or that they're the right masses. We have no evidence of that.
1 mass at 1 distance.
That's a 2 mass at 1 distance. But whatever, fine. He's going to say a 1/2 mass at the other distance.
From the pivot. And a 1/2 mass at 2 distances from the pivot.
Right, and from the pivot of a lever that doesn't have a counterbalance to it. So the lever itself is putting weight on the spring. So I pointed this out before, so I guess I'll draw it, right? Because it's, these are details they wish to pay no attention to. So you can sort of understand that if you have a regular lever and you balance the lever first, so you have a balanced stick, that you've already, no matter how fast you move the stick, no matter what you do with the stick is irrelevant because you've compensated for its influence. It's completely moot as an issue because, changes, not complicated what I'm asking you to do there, software. Alright, so in my analogy, I'm of course saying the lever has to be balanced. That is, you have the same amount of lever here that you have on this side. The lever has the same weight on it. So he's taking an object that doesn't have the same weight. Okay, it's not counterbalanced with an extra weight hanging on here to compensate for the extra lever he has coming out here. So what does that really mean? Well, it means that this weight of this lever, all of this much of it anyway, is extra weight. It's essentially another weight dangling. So now he's doing a comparison between the oscillating speed of when he has a 2 mass dangling here with it, or a 1 mass out here. And obviously its center of mass is now going to be completely different because you have to blend that, okay, with this. Right? This was the lever, the extra hunk of lever. So this is the extra hunk of lever is here. Okay, this weight. He has a 2 mass and he has a 1 mass. So you can just see it's like adding another mass to the lever. And so the total weight on the other side will be different because you're basically moving the mass to a different location. So this location here would be where these two add up, and say some location like here would be where this one and this one have their center of mass. So you've changed essentially the location on the lever of the masses because you have more than one mass on the lever. So you're changing how fast it can move because you're changing the actual weight you would feel because you're also weighing the lever. So if he had just done it where he just left the other end on the lever, then he would have a better experiment. It would make much more sense. But he didn't do that for whatever reason. Too much space, some other reason. But clearly, any honest person could acknowledge that, yeah, those do seem like different experiments. You know, counterbalance, no counterbalance. Yeah, that would be a different experiment. See, if he could put a counterweight on here to balance for that extra piece of lever, it wouldn't matter because then that would be moot. But there's no counterweight on here. Alright. So we'll turn that back on. Continuing.
When under influence from the same spring potential energy.
So again, you know, you can talk this baby talk of potential energy. Obviously, the energy is always in potential of something else. The sticks don't have the potential energy. The spring has the potential energy. You know, it really should be located in the right places. And the potential energy really is active in the sense you could bet there's little eddy currents running through the metal of the spring. It's under pressure all the time. It's pushing against things. It's active energy, and you're just saying, I've stored it, and now I'm going to release it. So when you say potential, you're really saying stored energy in the case of a spring. In the case of gravity, you're obviously talking about an active stream, and you're just going to stick something in the stream. Those would be the proper analogies.
Accelerate and move up in unison at the same speed.
Well, they have to conserve the momentum. So if you're going to get the same force out of the spring into the objects, they would have to move the same speed because you're supposed to have the proportional masses to distances. So if you have your masses correct and your distances correct, it's the obligation if you're going to conserve the momentum. As Professor Lewin said, nature can finagle kinetic energy, but it can't finagle momentum. And you disagree, and you should make that your public statement.
And that would mean that the half mass would be going at twice the velocity of the one mass. Therefore, conserving the momentum energy, as he calls it, you know.
Yes, I call it as physics calls it as a real thing. Conservation of momentum is a real thing.
They would have to go up at the same, in unison, in synchronism. But they didn't, did they?
And they didn't because your experiment's a piece of shit. That would be my argument, okay? Not because the physics doesn't work. You don't quite work right. The problem is in human error. The problem isn't in the physics. You're just a noisemaker, a buffoon, a fucktard, and a jerk. That's why it didn't work.
They really didn't. We showed that. This one mass accelerates quicker than the half mass because it's greater in that.
Okay, it keeps saying it, except the heavier mass was accelerating quicker when it oscillated with less amplitude. Now, it makes absolutely no sense to say it's going quicker when it's got less amplitude. The amplitude is a definition of its velocity. It has to have more velocity to have a higher amplitude. But whatever.
We showed that they don't go up in unison. Quite a big difference, Gary was saying, you know. Oh, look at that, look how...
Yeah, the experiment's a piece of shit. Yeah, that's what I said. And I'll continue to say it. It's clearly shit.
You know, there's a big difference.
So, yeah, so put the rest of the stick on the sticks, okay? So stick the rest of the sticks on the sticks, and then redo it, and see how it turns out.
So that blows his momentum energy theory out of the water.
Alright, so this doesn't obviously blow anything out of anything, any fluid. Piss, shit, diarrhea, whatever. This doesn't really do it, bozo. Yeah, to go with bozo, brozo. Sorry, no sale. Unconvinced.
Of course, so how did he get around it? He tries to say that there's more friction on the pivot than on the other that's slowing one down, because that's rubbish.
Yeah, of course. You proved it with nothing. So he doesn't have replaceable weights. He can't show us that, yeah, it doesn't matter what side he puts which weight on. It's all the same. He doesn't do any of that. So he doesn't have any controls here at all. So he doesn't even show us that if you put two masses in both sticks, that they would oscillate in sequence. That his experiment is good enough that if he has a 2 mass and a 2 mass, they would oscillate in unison. That would demonstrate whether there was any flaws in the bearings or the spring. But he doesn't do that experiment. I mean, those are called controls. You do control experiments to see if you have a defect somewhere. But he doesn't bother with scientific method. You know, what do I need that for? Science doesn't have a method. There's no rules. I just make up my own. I'll duct tape together my shit, and then I'll make declarations about the truth. No theory, no logic, and no real care in how he constructs an experiment.
So that's been proven.
So he says it's a proof. So he established nothing going into the experiment in terms of any of the details. He's just assuring us. I did everything correct and it came out wrong. You don't have any right to say I made a mistake somewhere. Yeah, I do. And I'm exercising it.
Momentum energy theory is nonsense.
So he just said momentum theory is nonsense. So you don't have to conserve momentum. So that's a theme among these people, okay? They won't say it, though. They won't say the absolute statement. They won't say, I disagree with conventional physics. Professor Lewin is wrong. There is no law of conservation of momentum. They won't say these fucking words, these lying pieces of shit. Do you see how they lie? They take no responsibility for what they're claiming to be true, because it is in direct contradiction to what every other physicist says, every degreed physicist says. I don't think there's any degreed physicists who say there's no conservation of momentum. So go ahead, make that statement. All right? And quit pretending this is about debunking me. You're debunking conventional physics. You stupid liars.
It's not energy.
So on to the new pile of shit.
Now up here, you'll like this, Gary. PE equals 1/2 kx squared.
So obviously I'm not right when you start writing all this horse shit. So this is just right back to what I did numerous videos on, where I've already pointed out how MGH is crap, that it's MGT if you want to get the right answer. It's about how long you're in gravity. It's not about how far you move in gravity. That'll decide how much energy you collect when something hits the ground, or how much energy you need to launch something into space. And those facts are reliable. NASA knows it does not pay per mileage gas rates. It knows that, see, NASA could lift a rocket off and just say, well, let's go 200 miles an hour and no faster. Why create all those fancy rocket engines and all that shit? Well, let's just use really simple ones, you know, and create a little bit of thrust and just take our time to get up there. Well, NASA knows that the longer it takes to get up there, the more fuel it has to use. So NASA knows the truth. That your silly theory that you're not using any energy, okay, by taking more time to go through gravity is an absolute lie. The longer you hold something in gravity, the more work you do. I mean, it's just a fact that conventional physics, their equation says this is no work. Me holding this, say this weighed 100 pounds, and I was holding it. They say because I'm holding it steady, it's no work. If I took 10 hours to lift it, you know, they would say it's the same work as if I took 1 minute, or, you know, 10 seconds, or 2 seconds. They say it's the same work. 2 seconds, 10 hours. Same work. That's their math. And obviously to anybody who lives in the real world knows that's absolute crap. It would take a tremendous amount more work. The longer you take holding the weight, the more work it is. So it's just stupid. So anyway, this experiment was already pointed, this, what you would call paradox, was raised by mindless marbles. And I did a video on it, and I explained how you're still stuck with a paradox. You're not solving the paradox, okay? It's a real problem, and you're just pretending it away and not making any argument at all. So I'll explain it again, how he's not solving it. You know, he's just sitting there and highlighting it and saying, look at this weird paradox. All right, but he's not calling it that. He's calling it somehow a solution. There's no solution here. No, it's just absolute garbage as a theory, as an idea. So again, this comes from these people not being able to, you know, they can build these devices, but they can't be bothered, you know, to take a crayon and write on a piece of paper and show us what the fuck they're talking about. All right, so we will explain it. So mindless marbles points out, okay, that I can have a weight, and I used, you know, just to make it simple, I used the idea of a staircase. Okay, and that'll just show you your height. Okay, so we're going to go 4 units of distance. So these would be the units of distance, here, 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 here. All right, and that's what he's, you know, he doesn't have it very well proportioned here, frankly, which is kind of silly. And so the truth that we all, I think everybody agrees on, frankly, okay, the Galilean truth, all right, is the fact that there's this curiosity that I can, okay, I can go 4 times the distance, and it will take only twice the time to fall. All right, it'll only weigh twice the weight, right? And it'll only be going twice the velocity. So even though it's 4 units of distance, that's all I'm going to get out of it. So for this whole section here, only produces 1/2, you know, it only produces 1 unit of weight. So if this was 1 unit of weight, okay, falling this distance was 1 pound, let's say, I only make it, this is only 1 pound. Because this will only be 2 pounds when it hits the ground. That's all I'm going to get out of it is 2 pounds. I'm not going to get 4 pounds. I'm just going to get 2 pounds of weight. So this is the paradox. Now the paradox is that, well, if I drop something, these 4 distances, you could say this was 1 pound, this was 1 pound, this was 1 pound, and this was 1 pound, right? This one distance. So that's 4 pounds total that I dropped. Now, you know, and I know, that if I had a spring and I hit it with 1 pound of energy and it compressed this much, let's say, that if I tried to drop another pound on it to make it compress some more, it won't compress anymore. So when I drop the second pound, it doesn't compress anymore. If I drop the third pound, it doesn't compress anymore. If I drop the third, no, it doesn't compress anymore. So it doesn't work, okay, in terms of adding it that way. I can't add it in series. I have to add it in parallel. That is, I have to take 2 springs already compressed and put them side by side at the same time, and then release the energy to get twice the compression out of the spring. So there's a little tricks, right? So you're saying, how do you fix this paradox? It's real. It's in their theory. So they're saying this is real, okay, that you really have 4 units of energy, 4 pounds of energy. And the argument they're making is that if you lifted something off and it only takes 2 units of energy, 2 pounds, 2 compressions of the spring, it doesn't add up, right? Because I could just keep doing the 2 energy thing up and I could collect the 4 pounds going down. So 2 pounds up, 4 pounds down. But the catch is that you can't collect this stuff because of this fact that you can't push the springs with the same 1 pound 4 times. 1 single pound hitting something 4 times will not create 4 pounds of compression. It will not compress the spring 4 times as much because it's only 1 pound of pressure. You could also understand that each time you go to collect the energy, you also lower the gravitational potential. And so each time you're losing gravitational potential with each time you dropped it. So you have to come up with some mechanism to get around those kind of details. But it just exists as a fact. So my simple point to you, Ian, you fuckhead, can't I defeat your whole entire argument by just pointing out to you that all I have to do is 2 units of energy? I just lift an object. Let's see, where's the best place to erase? I mean, I think we got this part, so we don't need it. So the point is that here's the 1 notch, right? Here's the 1, 2, 4. Okay, 4, 3, 2, 1. All right, this height here. All right. So this, dropping 1 mass from this distance will get me 2 masses of weight. Okay? So it'll equal 2 masses in weight on the spring. And also, so I have to lift it 4 units of gravity up. But I could just take 1 unit of mass and 1 unit of mass and just lift them 1 unit of distance. I could put them both up here, and that will weigh 2m. So I can get the same amount of energy in the spring, the same compression, by just lifting 2 1 masses 1 unit of distance. So that's only 2 units of distance I lifted, and I'm getting 4 units of distance of weight. So the paradox exists. How do you explain the paradox? How do you prevent me from turning your theory into a free energy theory by merely lifting 2 masses just 1 unit of distance and then dropping them together? How did I not just defeat your system and create free energy? Fuckhead. Yeah. I lift 2 masses 2 units of distance and I can create 4 units of distance in the launch. Fact. How do you overcome it? Alright. I mean, I did this video, and here he is, with this patronizing nonsense that I don't fully understand this crap, and I fully reject your theory that gravity is a per foot linear function. Of course it's not. So I've made this argument. I mean, will he account for any of the arguments that I've made? No. Will he counter-argue any of my arguments? No. I mean, these people are disgracefully horrid, awful, disgusting weasels. So I made the point. Okay, you have a gravitational body. There's a real fixed amount of gravity that radiates per distance, inverse square law. So you can know that there's a certain amount of gravity you'll be exposed to. That's significant. All right. So you're going to shoot your rocket, okay, pass through that gravitational field. What's the only thing that's going to matter? Well, the only thing that's going to matter is how fast you're going. How fast you get through the gravity. The gravity is a force pushing this way, and it's completely time dependent. The faster I go, the less the force affects me. The slower I go, the more the force affects me. It's so frickin' obvious, it's undeniable. How can you argue that gravity isn't completely about how much time you're in it? Again, do you really believe, you look like you work out a little bit. Do you actually believe that if I'm, lifting weights, that I'm doing the same work if I do it really, really, really slow, or if I do it fast? You think it's really is the same amount of work? The same calories will be burnt? Then I think you're really stupid, frankly. You're really fucking goddamn stupid if you're going to defend that mush. So go ahead, explain how it works in your brain. That gravity is a per foot, and it doesn't matter how fast you go, it's the same amount of work. So if you want to launch a rocket, just launch it at 500 miles an hour. Don't go any faster than that. It'll save you so much trouble because it's the same work, same energy. You don't have to use any more fuel because it's all about how many feet you traveled. It's not about how long you were in the gravity. It's just about how much distance you traveled. I think we know NASA can't do that. It can't rely on your dopey theory.
The potential energy of a spring is equal to 1/2 K, which is a spring constant, X.
So this is a completely made up number. Doesn't mean anything. This is just converting another way of just saying fake energy. It's another fake formula, okay? Like the work formula that's, work is force times distance. No, it's force times time. How long are you in the force? That'll tell you how much work you're going to have to do. These do not give you accurate numbers. This is a shitty formula. It has no value. It will not tell you the truth. It'll give you a fake number like 2,000 joules for the bullet and 2 joules for the recoil of the gun. It'll give you numbers that are absolute silly.
The displacement squared. So the displacement X. The potential energy.
So let's understand, NASA doesn't use this formula. So go ahead, show us where NASA uses it.
At the square.
I mean when it's in space.
Of the amount of displacement. It's a bit like 1/2 mv squared.
It's exactly like, that's where it's derived from. This didn't come first, you retard. This came after 1/2 mv squared. This is a derivative of 1/2 mv squared. It's not. This didn't come first, you moron.
Isn't it? It's funny that. And there's another one.
No, funny that, he says. No, it's not funny. 1/2 mv squared created all of these other fake derivatives. mgh, the work equation, work equals force times distance, and that pile of shit, all created by the wrong definition of energy, and all creating wrong descriptions of reality.
Stephen might know this one. It's the energy stored in a capacitor.
All right, so another fake term, the kinetic energy stored in a capacitor. So again, you show me where it's actually used and it actually gets real answers. So show us where they've proven the actual energy in the capacitor using your formula. Show me that it's any more reliable than their joule numbers, where they say the 5-ton train going 10 miles an hour has 250 joules. And then they say the 10-ton train going 5 miles an hour only has 125 joules. Show where they prove that ever. Ever. Ever.
mv squared, capacitance times the voltage squared. There's lots of these 1/2 formulas.
And I'm saying anytime you find one of those formulas, you ought to be a little bit suspect, because it makes absolutely no sense to square a one-dimensional vector.
You know, in physics, it's been a thing for a long time.
No, it really hasn't been all that long, okay? And, you know, certainly in those mathematical formulations. They didn't come up with that shit till the 1800s. So from Newton until the 1800s, it was just mv squared. That was it. Just some wacky notions, okay? No 1/2 in front of it.
So this potential energy of a spring, you keep going on about springs are linear with the weight. It's true, that's hooked.
Okay, well, you just said I keep going on about, and then you say it's true. So maybe people should keep going on about the stuff that is true. Yeah, I keep going on about it because it is fucking true, and it's fucking critical to all these measurements. You're saying that a spring's compression isn't energy, and then you're going to use a spring's compression to create energy. Do you understand how insane this is? Springs don't have potential energy. They don't hold kinetic energy. They don't do, and then you're going to use them to make energy. Do you understand that that's idiotic?
Law. You put a 1 pound weight on a spring, it will compress so much, and you put a 2 pound weight on the same spring, and it will compress twice as much.
Right, and if you drop it, you'll get the same effect. That's the whole point. So you drop it from 4 times the distance and you only get twice the compression. That should be a giveaway that something's amiss. That, you know, this idea of this 4 number, it doesn't seem consistent. 4 times the distance, twice the weight. That doesn't seem right. And as I point out, I can easily defeat it as an experiment where I can just prove how it can't be right. It can't work. Okay, that you have to understand it differently. The distance just doesn't matter. It's about how long you're in the gravity. You can only gain energy from gravity while you are free falling in it. Period.
Yeah, that's not energy.
So he just said it. It's not energy, and yet he's going to use it to create energy. He's going to launch a fucking projectile with it and then claim it's not energy. The spring compression that causes the object to be launched is somehow not energy. What the fuck is it then? Benergy? Kinenergy?
It's not the energy of the spring.
So he just said it. He's going to use a spring to launch an object. He's going to claim the object goes a certain amount of distance, proving it has energy. And he just said springs don't produce energy. I mean, why do I have to? I shouldn't have. This is beneath my pay grade, so to speak. I should not have to interact with people this incoherent, self-contradictory, and irrational. This is garbage, rubbish, mush talk.
The spring goes at the energy goes at the square of the displacement.
Well, go ahead, prove it then. Show it. Show the extra energy. Because you're really not. Again, Galileo could explain to you why it goes twice the distance, because it's only in the gravity twice as long.
We're going to show that.
So he's not going to show anything I haven't talked about or illustrated at least 100 times on this board. 100 times I have drawn this and explained this, and he's showing it like he's revealing something that I didn't already explain explicitly. And he's confirming exactly what I said, which was, you have to understand, people, I dropped something from 1 height. You know, I get a compression. I drop it for 4 times the fucking height, and I'm going to get twice the compression. Huge fact. And they say it confirms kinetic energy? No, it confirms you have a problem. Your theory is very, very broken. Because this is energy. This is an energy measuring device. It produces the stimulus that creates projectiles. It creates energy in the universe. It stores energy and releases energy. And it's showing you overtly 4 times the height is only twice the fucking energy.
We've got here a weight sliding up this tube and then weight.
So look, he's going all the trouble to build these things, right? Now, will you build the simple lever launcher? So just make the Brozo experiment, right? And prove that levers don't work, that they don't conserve momentum. So all of this absolutely confirms everything I have said. So he's not demonstrating anything that is that I haven't already overtly described over 100 times in my videos.
Got some springs. They're separate springs, but when placed together, they act as a longer spring, so we can get a bit more.
Right, in series. So, and the fact is, if you dropped a mass from one distance 4 times, it will not compress the spring twice as far. It'll just stay right where it is. It won't add.
Now, to make a quick release mechanism is a lot of effort, to use an old expression.
Look, so go ahead and just say, I'm just doing a casual experiment and it's okay. But don't try to rationalize that professional, well-done experiments shouldn't have quick releases in them. We all should be advocating for the highest, careful, meticulous standards in how the experiments are done. Here you assholes are saying it's okay to do it a little bit sloppy. It's okay to cut a few corners. Should you be saying that? In all honesty, do you really think that's what physics needs, is corner cutting? So, I mean, at minimum, just say, okay, I'm not doing an experiment that I want to be, in a museum somewhere as the perfectly done experiment. I'm doing it just to show that it's practical theory, that this is what usually happens. We don't need to get the exact answers, so we're not doing a qualitative experiment. So just make excuses for the fact you just don't feel like putting that much energy into it. Fine, but don't sit there and try to rationalize or create defenses for the fact that you're not doing it the way you really should be doing it. And frankly, the amount of pressure you're creating to launch that object up that stick is a lot of pressure, and you really should have a quick release. And you're just fucking around. You're not doing science any favors by saying it's just okay not to bother with these details. Isn't that the whole problem? People not bothering with details? Fuck you.
Its moment is of no great importance in this experiment. It's a visual thing to give you an idea. That we're going to show that by compressing the spring one distance, we get a certain amount of height. That by compressing the spring 2 distances, we don't get twice the height, we get 4 times the height. Yes, it goes at the square of the...
So it doesn't go at the square. So again, that's just stupid. It doesn't. Okay, go as. I mean, it's just a stupid way of saying it. It's going twice as fast, and therefore it goes through the gravity in half the amount of time that it would have taken, okay, if it was going 1 speed. So instead of taking 4 units of time, it'll only take 2 units of time.
Right, here we go then. I've got my marks here. I'm just going to repeat it. So I'm going to do it several times to give you an idea. So this is one displacement.
So you could see that didn't even make it to the line, and that's because he's not using a quick release. So he doesn't have a standardized release, so each time he lets a little more or less energy into the system. But anyway, again, this is nothing. This is not a proof I'm wrong. This is completely validating everything I have said. So why is he doing it? Why doesn't he just say, yes, I agree with Gary that, yes, twice the spring compression will create 4 times the distance in gravity? Because all you have to do is say those words and you've already confirm that, yes, you understand kinetic energy can't really be realistic. Because I can create twice the spring compression by just putting a 2 mass here and dropping it. Game over.
Give you a rough idea. I know it's a bit fast. I need a slow-mo camera. They're a bit expensive, aren't they? That's one displacement. I think it's going up about
So I just point out again that this was done pretty poorly in this fact that this unit from this place where the weight stops is not the same distance as all these other units of distance. So it is a little sloppy in that regard also. So he gets answers that are like 0.75 to 1.5. Huge variety.
Coconut shy bloody hammer thing, in the fairground.
Right, and it's only twice the amount of energy. Again, all I have to do is lift 1 mass here, 1 mass here. So all I have to do is travel 2 units of distance, put 1 mass up 2 units of distance, and I'll gain the same energy as that launching speed. I'll compress the spring the same amount as it took to launch the object those 4 units of distance. Fact. Now explain that fact with your theory.
Whack it with a sledgehammer. One displacement. One displacement. One displacement. 2 displacements. 2 displacements. Lift it up there.
So it's all about time. So if I put a 2 mass here instead of him having a 1 mass, and I drop it the 1 unit of distance, because the energy is hitting at the same time, okay, it will compress the spring twice as much. The spring will see 2 units of mass, and it will compress 2 units of mass. And now I'll be able to launch a 1 mass 4 times the distance with that same energy. Clearly, it can't be 4 times the energy to get up there because I only put in 2 units of energy to create the compression in the spring that allowed that launch to take place. Clearly, NASA tries to get its rockets to go as fast as it can, to get through the gravity as fast as they can, because they know the slower they go, the more fuel they'll need.
That's 4 times the height.
So he's all out of breath. So it's not in very good shape, I guess.
Perfectly accurate, but it's enough to give you the idea. Now Gary would say, oh well, 4 times the height doesn't require 4 times the energy. Because he says you can lift it fast and do it for less energy. What a load of nonsense that is, isn't it?
Alright, so he just said it's a load of nonsense. So he's actually saying that NASA theoretically could get into space, by just flying like an airplane and just slowly increase its altitude and slowly increase the altitude until it got into space. And that it could do it that way. That wouldn't take hundreds of times more fuel. Of course, it would take hundreds of times more fuel to do it that way, because you're in the gravity so much longer. You could be in the gravity for hours, so it could be thousands of times more fuel. NASA knows that. That's why they don't do it the gentle way. That's why space rockets don't gently go into the good night. They try to get there as fast as they fucking can.
Because if that was the case, we know that if we drop a weight from a certain height, we can recover the energy from it. And if we lifted it 4 times as high, to have twice the velocity,
He really is out of breath. Yeah, that's if you let it free fall. Now, if you drop it one step at a time, it'll never have twice the velocity, and therefore it'll never have instead of 9 pounds of pressure, it'll never have 18 pounds of pressure. It'll just have 9, and then 9, and then 9, and then 9.
That's 4 times the energy.
So it obviously isn't. In free fall, it's only twice the energy. Because it's only twice the time in gravity.
Now, if we could recover that energy and lift the weight faster up to that height, using less energy to restore it, we'd get out more than we were putting in.
Right. That's if you can collect it in 1 pound increments. So that's the catch. So you show me you able to collect 1 pound, 1 pound, 1 pound, 1 pound for 4 pounds. Okay, and then yeah, you've done your job. But that's the problem. You can't collect it that way. So until you figure out a mechanism where you don't lose too much energy in the collection process, your 4 experiments mean that you have losses in each one of the experiments. You doing it in 4 increments mean you're losing energy, you're losing efficiency 4 times. If I launch it at twice the velocity, I'm only doing 1 experiment. I only have 1 set of losses. You have 4 sets of losses. That's probably one of the reasons why we can't do it.
If it's nonsense about...
Okay, so if you're nonsense about this 4 times the energy thing, how come I can defeat it by just lifting 2 one masses, 1 unit of distance each, which is just 2 total units of distance. That's all I had to lift was 2 units of distance into the gravity, and I've created the energy necessary to launch something 4 units of distance. So explain how your theory allows that paradox to make sense.
It takes less work to lift a weight to a certain height by lifting it quick. If that were true, we would have free energy.
No, we wouldn't. We'd have what we see all the time. That's why they call it clean and jerk in weightlifting. Because the whole idea is jerking the weight as quickly as possible, getting it to your locked position as quickly as possible. The sooner you can get under the weight, the sooner you can, have the gravitational potential go through your bones and all that kind of stuff instead of you having to push it with your muscles. You win. But I mean, anybody with any kind of experience, just hold the book in your hand and see how tired you get. Because it's showing you that that's work. You're fighting the gravity all the time. Time.
As we know, we can get a certain amount of work out of a weight from a certain amount.
All right, so there's no work, right? There's no 4 times the work. The spring is a measure of work. Okay, so it's clearly telling you. This is a work measuring device. It's telling you work. It's showing you work. 4 times the height, twice the work on the scale. The scale only says twice the work. So quit lying, okay, that you have some evidence that it's 4 times the work. Show us 4 times the height making 4 times the work. Show it doing 4 times the work. Show it.
But if we can use less work to restore it to that height again, by doing it quicker and quicker, you can have over unit thing, aren't you? What a lot of rubbish.
So again, you can say it, but you haven't fixed that dilemma. Because I can defeat your theory by just simply lifting a 2-mass object 1 unit of distance, and I will create the same compression in the spring by only using 2 units of distance.
Potential energy of a spring, Gary, one last time. Potential.
No, I don't need your equations. I'm in full dispute of them. I'm saying you have absolutely 0 real-world evidence that that formula is correct. You have 0 experimental evidence demonstrating you get more heat, more work, more electricity, more anything using that formula. So show it doing 4 times the work, and then you can make your argument, or 8 times, or 16 times, or in the case of the bullet, show the 2,000 joules. That means 2,000 units of heat 2,000 watts of energy created by the bullet versus the recoil of the gun. Show that the bullet can do the 1,000 times more work in the universe before you declare it a truth. Show me one experimental experiment showing it.
Energy is 1/2 spring constant K, the displacement squared.
Bullshit. So just write MGH and I'll say bullshit. Write work equals force times distance and I'll say bullshit. None of them proven, no experiments showing that to be the truth. No experimental evidence. You have absolutely no real qualitative experimental evidence that you can make more heat or that you can demonstrate any fact that you created this 4 times the energy.
X squared. It's not Hooke's law. Hooke's law's nothing.
Now again, no evidence ever provided that it takes 4 times the fuel to move something twice as fast. No experimental evidence, nothing, 0. And this arrogant putz talks this shit when he has no evidence to support his arguments.
Thank you.
Fuck you. Alright, so we'll do some comments. Let's see if there's anything in the the shitty little chat. Sorry, chatters, but I have very little confidence in you. Man, my back hurts. Oh, come on. Long day at work. Yeah, I'm sorry, too bad. Long day of being alive here also. So, dropping a 1 mass on a spring from 4 units of distance is the same as dropping a 2-pound mass on the spring from 1 unit of distance. Yes, he pretty much just showed you that in inverse. So he showed you, and Galileo would argue, right, whatever you do going up, you get exactly the same shit back. Einstein would say that. All the physicists would say gravity is completely proportional. Whatever you give to gravity, you'll get back. It's a very good spring, gravity is. So yes, whatever you can say about stuff falling, you can say about stuff going against gravity. So that's exactly the truth. And he doesn't think he has a paradox problem. Yeah, pretty stupid. All right, how much time did you need to drop each mass? You're letting it go. It falls in gravity at 9.8 meters per second. The fact is that at this first second, it only goes 4.8 meters. In the second it goes 19 point something meters, or whatever it is, 24 meters or something. It goes a lot further in the second because it's going a lot fucking faster. What do you think of Elon Musk? I think he's one of the scuzziest humans. I mean, he's not Trump, but he's almost a little junior. He's like the Trump mini-me. He's a fake, phony, and a fraud. He doesn't know he doesn't know shit about anything. Okay, he has no science knowledge. He's a fucking capitalist pig. Okay, and all he does is he creates little rackets and gets a bunch of suckers to invest in it and lose their money, just like Trump. Trump takes the free part, and he has a bunch of investors lose all their money. I mean, Trump didn't go bankrupt 6 times, right? I mean, he went bankrupt 6 times, but he didn't go bankrupt 6 times. The people who invested in his bullshit went bankrupt 6 times. Fucking idiots. Anyway, I mean, really, fuck you people in this crap comments. Man, this guy is so glib. Gary, you really should get paid to deal with these fools. Yeah, well, yeah, deserve has nothing to do with it, right? So people don't get what they deserve, and it's just a sad fact of this life on this scuzzy planet that most of the humans wouldn't even vote for the people should get what they deserve law. It's just a fact, right? If I was to propose a law in Congress that people should get what they fucking deserve, that should be our job as human beings, is to make sure people get what they deserve. People wouldn't vote for it because they know that they deserve to get somebody's goddamn foot up their fucking ass because they're jackasses. They're thieves and crooks and liars and phonies and frauds. But anyway, enough of that. Why don't you use a calometer to measure energy. Well, what exactly is a calometer, for fuck's sake? I mean, we're going to burn everything and find out how many calories are in it? I mean, come on. Like using a, I don't know what that is, a blender with a known rotational speed. I'm sorry, this doesn't make any sense. To measure the temperature increase of water. Yeah, we're back to Joules experiments, right? You want to do all that crap? You want to precisely make a insulated water barrel and then make your own thermometers and go through all this horse shit? And the big flaw in Joules experiments was he dropped things in gravity. Instead of tying it to a horse or, tying it to an electric motor, he kept dropping things in gravity. Gravity being this bizarre, fact that you can travel 4 times the distance and we get twice the energy. He has no respect. He has no respect to doing accurate experiments. He has no respect for the scientific, all of these bullshit statements about how science should be done. He just doesn't care. Let's just do it all sloppy in our garages and declare the truth. I mean, that sounds like free energy nuts, right? I mean, they whip up their silly little tinfoil hat kind of experiment and then say, look, I've proven. Just a poorly done experiment. Cool videos. What do you think of... oh, fuck this. I'll just block you, Jim. Alright, this isn't about mud fossil. What the fuck are you talking about? He also discovered all matter. I mean, he believes, some kind of frog runs the universe. Why do I have to bother with this shit? Alright, so I'm just going to block you. Yeah, fuck you. This has nothing to do with this. That has nothing to do with this. I'm not religious. I don't have any creation theories. I'm not proposing, like you wacky fuckers, entanglement. I'm not proposing ESP particles. You're the ones with the mud fossil fucking theory, you fucking piece of shit. Fuck off. Alright. The big thing that should be understood is the longer you are in gravity, the more energy is needed. Well, I'm just saying the more energy it gives you, or the more energy you need to oppose the force you're collecting. You collect gravity based how long you're in it. It's a paint sprayer. It sprays you with the energy. The longer you're exposed to the spray, the more paint that gets on you. It's that fucking simple. NASA knows that the longer a rocket takes to get out of Earth, the more fuel is needed. Yeah, well, there's all kinds of complications, right? I mean, you always heard that power-up thing, right? When the space shuttle blew up, when they were doing the power-up thing, because they can't go through the heavy atmosphere as fast as they like. See, they'd like to shoot the rocket really, really fast, but it doesn't do them any good because the atmosphere is creating so much friction that they end up with a terminal velocity. They end up stuck, not being able to go any faster because the atmosphere gets heavier and heavier that they're pushing. So they have to wait till they get high enough in the atmosphere to really let the throttle, to step on the gas pedal. So they don't really step on the gas pedal when they're launching. They step on the gas pedal after they get above most of the heavy atmosphere. Then they step on the gas pedal. And that's when they really start doing the Mach 5, Mach 6, Mach 7, Mach 8. That's when they really start going fucking fast. Alright, so I guess we're caught up. I will go to... unfortunately I have to move this thing. Okay, well next time I'll move it. I should just pop the chat out, but I just... I see I have so little enthusiasm. You people just inspire so little enthusiasm. Has Tony made any new videos? No, I don't think he's anything since... I mean, he did the one with the, he put a ruler on top of a pencil, a plastic ruler on top of a pencil and said, there, I've just proven Gary's right. That's not a very good way to prove me right, frankly. You really, I mean, you really shouldn't be making the argument that that's all we have to do is, really crude, cruddy kind of crayon experiments. They should be made out of a little better than that. But whatever. The other pendulum thing was pretty good. In terms of demonstrating at least the minimum, that logically you would say that when something with twice the energy hits something with half the energy, well, half as much as the twice, that the thing with twice the energy should smash the collision, and the collision should go in the direction that the thing with more energy has. That would be the rule. And he proved it's not the rule. Okay, kinetic energy doesn't work. It doesn't win the tug of war. When you talk about lifting 1 mass 4 units of distance, you say that gives a 2 mass. I don't know what you mean by that. No, I didn't say that. Whatever. It lands. You take a 1 mass and you put 4 units of distance up in gravity. It lands with twice the mass, twice the weight. Weight. You got to use the word weight here once in a while. When it hits the scale. So it doesn't hit the scale with twice the mass. It hits the scale with twice the weight. Alright, but since it's going to velocity under the KE regime, the force is 4x compared to 1 velocity. I'm sorry, it isn't. There is no 4x force, okay? It only compresses the spring twice the fucking much. So you keep saying, what the fuck are you saying? Well, according to, yeah, we know. According to them, there should be a 4 on here. There's only a 2. It should be a 4. God damn it. Yeah, that's why I hate people. What the fuck? Yeah, we know what I'm arguing against it, so why don't you show me the evidence of that? I'm saying the spring does measure energy. Springs produce energy. When you compress a spring and then release it, you shoot energy into the universe. You can shoot a projectile, and you can say that projectile is a 10-ton train going 5 miles an hour, or it's a 5-ton train going 10 miles an hour. You can call it something, and you can say it has kinetic energy. So clearly the spring produces kinetic energy. And my argument is clearly you could see it stored. I can put numbers on the spring, and by Hooke's law, okay, it's just a fact that twice the compression, twice the energy, twice the weight. Twice the capacity to push the fucking thing. Twice the fucking force. Oh, man. I mean, fuck you. It's not an instantaneous weight measurement. Fuck you. It doesn't have to be. It is the instantaneous weight. Drop it on a fucking scale, asshole. It's a fucking instantaneous fucking goddamn weight, you fucking idiot. God, what a fucking asshole. Yeah, it is. You're measuring its total capacity. You're absorbing its energy, and springs do it fairly reliably, like whatever, with 85% efficiency. There's probably better things than springs, like pressure vessels or some other kind of material you could come up with that would be better, even more elastic than a spring. But that's what it's doing. It's storing the fucking instantaneous impact energy of the object. It's absorbing its energy. It's decelerating the object while it accelerates. I'm really starting to dislike you, Tim. All right, the scale is a good way to measure energy from a spring. It is a spring. Yeah. So yeah, it's a good way to measure spring energy with a spring. Yes, I agree with that. But besides it being a good way to measure spring energy, it's a good way to measure energy. Fuck. Why don't you tell us the right way to measure the energy, you fucking piece of shit? If you push a spring at 10 pounds, you get 10 pounds back. Yet, any speed is the key point. The spring can release at any spring. Like the lever, it can do the conversion. The spring can release the energy slowly, or the spring can release the energy quickly. See? Slowly or quickly. So I can put a 2 mass on, get all the energy back. I can put a 1 mass on, get all the energy back more quickly. fuckers. I'm going to quit reading these comments. You people are just too stupid. Oh, God, I just hate this planet. Alright, so let's watch this. Let's look at some of this horse shit that the little minions type. Nice documentation, Ian. And Ian says, I am trying, John. So what is he trying? So where's the trying part here? So he vaguely just says, my pendulum's perfect and approved, and then he threw that to the side. And then he spent the rest of the video demonstrating exactly what I said. Word for word, pretty much, exactly what I've drawn, exactly what I've said for 2 years. And said somehow he made an argument defeating me. Pretended he somehow was saying something counter to exactly what I've been saying. Fuck. Brilliant and clear demo, Ian. Hope you get your breath back. Yeah, I wonder where he lost it from. He is going to love this. Your name will be Mud, LOL. I don't know what that even means. Who knows? So let's see. Oh, we don't have any more from the Brozo. I hadn't finished watching when I made my comment. Oh, so there's another comment. They're both 4 hours ago. Otherwise, I would have said, wow, that's spectacular. So what I have been saying for at least a year, more than that, he says, wow, that's spectacular. Completely confirming exactly what I would predict would happen. Okay. And so obvious now, you've shown us all. Shown us something I've drawn hundreds of times. Okay. Michael just messaged me briefly to urge me to look at your demo. I was halfway through. It's still only 3/4 through. Yeah, it is a little boring. I had trouble getting through it all the way at once, too. Why does Gary never show us anything worth watching? Because I'm talking about the theory. How do things actually work? That's what you won't go near. You have to explain why it works. You can't just say, here, look, I did an experiment. That was 4 times the energy. You can't do that. You have to explain the mechanics of the system. What's making it happen? Idiot. Whoops, caps on, never mind. Somehow I didn't know that. I don't know. That's a little unbelievable. More lying. You make a great teacher, Ian. So what did he teach us? How to be an arrogant douche? Yeah, okay, he did do that. Yeah, so if you're trying to be an arrogant douche, this was the right video to watch. All right, and if he were, he would certainly ask us what the single equation would be that gives us the height straight up from the in the video given equation W blah 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 is a good luck with it. And good luck with it. I can't make any sense of that. He would certainly ask us what the single equation would be that gives us the height straight up from in the video given equation. I don't know what he's talking about. Let's see. Suffering really bad at momate. Science is out of the question. Oh, isn't that too sad? Anyway. Yeah, Gary claims that voltage is never squared. So, yeah, I'm saying if it's squared in an equation, maybe some other part of what's in the equation should actually be the part squared. I mean, sometimes you can square a component, and it doesn't matter because you're multiplying two things. Like, technically, you could square the mass, and if you weren't paying any attention, it would be the same answer. Anyway. And that I don't know the difference between volts and amps, LOL. Well, you clearly don't know that you can't measure the energy unless you're measuring the watts. So you clearly don't understand that mass and velocity make energy, even in your formula. And you have to understand you have to collect both of them. You can't measure one of them and say that's the energy. That's stupid, fuckhead. And that's what you've been doing. I'll just measure the speed. I don't care what the mass is. That's what you're doing. asshole. Okay. I'd pay good money to see him sit an electrician's exam. I openly admit I'm rusty now. So he wants to do the contest, but then he's already making excuses for why he's going to lose. What an asshole. Not forget about your question, mate. What, there was a question somewhere? It's just been a grueling 3 days. Not just with COVID or whatever I've actually got. So now he says he has COVID again, making it difficult to eat anything at all. Hardly half a pack of noodles was progress an hour ago. Let's hope it doesn't come back to bite me. Oh dear. I still have my sense of humor though. Oh, whatever. I'd rather have COVID. Michael's having a grueling time too, for different reasons. Hopefully he won't mind me saying nothing bad. He's just a very hard-working fellow with more balls than Gary can ever hope to have. Yeah, he's got him in his fucking head. You know, he's got everything in the wrong fucking place. He's got his head up his ass, okay, and his balls in his head. Alright, he's be back soonish, in case you wondered. Oh yeah, we all wondering. Great work here, Ian. I really like your communication skills. Obnoxious, pontificating douchebag? Yeah, oh yeah, that's great stuff. Shame it falls on deaf ears. So, it doesn't fall on deaf ears. I waste a great deal of time reading your shit, okay, explaining why you're wrong, and you asshole cowards pay absolutely no attention and never respond to any of the arguments I've drawn on the board, including this Ian Gostling coward creep. He obviously hasn't paid any attention to the last 100 videos I've made where I've talked about the 4-to-1 thing 100 fucking times. Oh, what disgusting characters. Repugnant. They are. Alright, so we'll go and pop the chat. And then we'll get the fuck out of here. Where the hell did it go? Yeah, it must be somewhere here. That looks like it. What the hell? You can't rely on anything you touch in fucking YouTube. Alright, so it didn't show up, which means it's didn't find it, which means I have to go find it, and means I have to put it there. There it is. Okay. Let's see, a little smaller is necessary, I believe. Alright, let's see what we got in here. See where we left off. I don't know. Bad day. Scale's a good way to measure energy from a spring. Yeah, okay. And then this. Gary, I'm just trying to understand your view when my understanding is uncertain. No offense intended. Well, I'm just saying you should phrase your questions in a different way then, or your points, and say, well, conventional physics says... Okay, you could say something like that, and then I could respond by saying, well, conventional physics is a pile of crap. You know, why don't you ask conventional physics to show you? Ask them to show you the experiment where, you know, it took 4 times more fuel to go twice as fast. All right. They should show why your work doesn't work according to them. They should explain it. I'm just saying, explain how a lever works. If it doesn't conserve momentum, explain what the fuck it does. So Brozo's overtly telling you that if I have a lever oscillating, and this side's oscillating with twice the velocity because it's twice the arc, because I'm closer to the fulcrum over here, he says if I launch those objects, this one will go 1 velocity because it's only going 1 unit of distance, and the one going 2 units of distance will only launch going 0.4 faster. It won't go twice as fast. Even though it's going twice as fast when it's on the lever, even though the lever's moving at twice as fast, it won't leave the lever still going twice as fast. Somehow it will slow down an insane amount. That's his fucking wacky theory. And he's going to prove it. He's going to produce an experiment that proves it. So isn't that going to be great? We're going to see the experiment where he actually proves that levers don't conserve momentum. Okay. Just can't wait. Yeah. Oh, it's just pathetic. They should show why. Okay, they just lie. Well, they do more than just lie. They pretend they know what the fuck they're talking about. Like they researched anything or they paid any attention. And they haven't. They haven't looked up Leibniz. They haven't looked up his arguments. They haven't looked up the counter arguments to Leibniz, where it was clearly pointed out it's a free energy formula. If we believe what you're saying, then we can make free energy machines. All right. They are obligated to explain. They should be. They're obligated by integrity. Integrity says you're obligated. But if you don't have integrity, you're not obligated. That's the catch. People with no integrity, no obligations. That should be the great video coming from Brozo. Hopefully it will be an honest show. Well, you could say it's going to, hopefully be an honest. I mean, obviously he's going to try to break his first experiment. See, because he has the wrong answer. So he's going to try to force it, to come out his way. And so he's going to have to figure out some way to make the heavier object move faster. So the faster object looks like it's moving slower. It's just look, if people don't know these certain little facts, they're going to fuck up. Like Franklin Hu made 2 videos and they were both crap. Because he really didn't understand how friction worked. And he even said in the video, I really don't know, whether friction's linear or it's not. So he doesn't know the answer to a basic question, and yet he's using friction to collect the energies, you see? So it doesn't work that way. You really have to know what the fuck you're doing. Or else then you have to do it alternate ways so you can just figure out, you can demonstrate how the answer is different if I assume one thing or if I assume another thing in the experiment, I'll get different outcomes. But clearly, if you don't understand the idea that something heavy loses its energy to friction faster, and that something going slower loses its energy to friction twice as fast. I mean, it 4 times as fast. It only goes 1 unit of distance compared to the 4. So you can understand it's only 1 unit of time moving. So everything that happens to it happens much quicker. It loses its energy to friction much, much quicker. So you can't, launch something, let it travel, 10 feet or 5 feet or 6 feet, and then crash it into something. You have to measure its velocity at liftoff, because the slower object's going to lose its energy so much faster. So that happened in Dispar's cracker experiment. Because they let the cart travel so far before it hit the cracker, the heavier car had lost a tremendous amount of its velocity by the time it hit the cracker, because it loses it so much faster than the lighter, faster car. The lighter, faster car takes a lot longer to lose its energy through friction. So it had so much more of its original speed when it hit. So it hit with 80% of its velocity, where the 2-mass cart hit with 20% of its original velocity. But if you don't know this stuff, all kinds of mayhem can take place. Brozo, like I said, I called him eccentric years ago. But yeah, I mean, that's another word for jerk, asshole, douche, fuck up, smelly. He's a lot of things. And none of them particularly great. No, none of them particularly good. Many of them substantially bad. But it's funny how they they catch each other's COVID, so to speak. They catch each other's bad memes. And so Brozo starts defending not doing quick releases, and you see Ian talking about it like it's not important. When everybody should say, yeah, most of the time you want to use one because it's safe. I mean, if you're not going to do the experiment right, then just say, look, I'm doing a proof of theory experiment. I mean, that's what I said when I did my experiments. I said, I'm just proving the theory. Brozo says it's 1.4, so I did an experiment, showed I got 1.8. So I just wanted to prove that proof of theory. That, yeah, no, I can do the experiment, and I'm not getting Brozo's results. I guess I should change the title of this video. Maybe I'll just put Ian's name in it and just say, okay. Because, yeah, most of the video was about his video. See if he can manage to coherently respond to the points made. Alright, 2-minute warning, I guess. Commenting is kind of thin. How many viewers? 11. Not great. Are you going to write a book, Gary? So I don't know why people keep doing this book thing. Frankly, not too many people read books anymore. It's the internet age, So if I was going to write a book, that would be like saying, well, Gary, you want to make a scripted video? Yeah, I could probably make a scripted video. Yeah, do I want to try to take everything I'm trying to say and put it into an ordered, well-constructed, organized description? Sure, I want to, but it's a lot of work. So I have to grow the food, I have to cook the food, I have to process the way. I mean, I have to do everything. Yeah. So yeah, we'll see. Maybe once the simulation is completed, I might try to do some of that. But it's not, frankly, it's not one of my strong points. I really hate writing because I see writing as being much more explicit. You can write something, you look at the sentence, and you have a chance to fix it and make it better. And so I constantly want to fiddle with the words and say it better, and it's just it does waste an awful lot of time. Well, I'm just saying the book is just going to be the videos. It's not going to be something else in the book besides all the crap I've been talking about for 10 years. I don't know if you could ever do physics with perfect symmetry, in the sense that each subject is a subtly different subject. Gravity's a little different than charge. Charge is a little different than electricity. Electricity is a little different than magnetism. So it all does have a, it's hard to pick a place and say, here's where you start. Because it is all circular. They all tie together. And so you're almost cheating it a little bit by pretending one thing is the core thing and everything else is, emergent. They're all just expressions of the same simplicity. The same 2 plus 2 plus 2 physics is doing all of them. Same information, different medium. I don't know. Yeah, I and I'm just saying, I just don't think it's a medium that is growing in popularity. I think it's shrinking in popularity. People like audiobooks. I do personally love them. And then I like videos where people explain something. So frankly, I just don't think in the modern age people should say book. They ought to say a concise compilation of your 10 years of research and contemplation. Yeah, okay, yes, maybe I should do a concise compilation. Whether it should be a book or something else, who cares? I mean, in theory, if I have 5 more years here on Earth, who knows how long I have, the simulation might get to a point where I don't have to do anything. You just hit the button on the simulation and you can watch the evolution. Do you think the major tenets of the big... Oh, you're doing that again. I just fuck you. Of the Big Bang will have held up in 100 years' time. I don't think... no, Einstein's theory is going down. Relativity is going to crash and burn because it really doesn't fit with quantum mechanics at all. And I just don't think there's... The Big Bang as described as creating free space is silly. So it doesn't make any sense. Space isn't expanding. It's either an explosion or it's not. And I think singularities are nonsense, so they'll disappear when Einstein's crap disappears. And you'll be stuck more with condensed stars like neutron stars. And all the question will be is the neutron stars get bigger, and then they get smaller, and then they get bigger, and then they get smaller, and then they get bigger, and they get smaller. I think the oscillating, some oscillating style universe will be the end product. The matter condenses, the matter uncondenses. The matter condenses, it uncondenses. But who cares? It's just such a distant subject. It's so far from what should be physics. I mean, it really is more like a religious subject. You're just going to have to make up some idea of creation. And to me, it just doesn't matter. Once you know creation isn't intelligence managed, then fuck it. Who cares? Once you know it's a retard, does it matter whether it's a green retard, a blue retard, a short retard, a tall retard? What's the difference? A retard's doing it. Why do I care whether the retard wears glasses, whether the retard, has 3 t-shirts on? Does any of that make any fucking goddamn difference? Really, I mean, if a retard is driving your bus that you're on, do you really care whether his shoes are tied or, whether he's got his finger in his nose or, do you really care? The universe is a mechanical process. Descartes, the Jesuit, who wouldn't become a regular preacher, so I think he was just trying to keep himself from being killed. Anyway, Um, he was just right. It's just a mechanical system. The energy just travels from piece to piece over and over and over and over and over. It just moves from place to place, bounces around inside the container. And that's all there is. One thing radiates light, the other thing collects the light. It's not that complicated. Yeah, I just don't get it either. I don't get it like I said, I don't get it for two reasons. First, I just don't care, okay, what kind of retard created the universe. Second, we can't know it anyway. There's no footprints. There's no way to follow any evidence. There's just nothing, okay? It's too far away. The facts, the scene of the crime, the house was blown up, okay, with a hydrogen bomb. It's like going back to Nagasaki and, trying to find, somebody's crib that they were born in. No, it's been atomized. It doesn't exist anymore. Okay, you're not going to find it. You're not going to find, your creation truth. But yes, it always seems like a desperate effort to try to force the universe to be human glorifying. Our consciousness is controlling the experiment. I mean, the woo is all over the place. If a window is open on a sunny day, photons are flying around. Close the window with blackout curtains and it's pitch black. Aren't the atoms still jiggling, but are they not producing photons? I have no idea what you're saying. A photon is a pattern, and if you block the pattern, it doesn't get through to something else that can reflect the pattern or enhance the pattern. When something gets hot, I could theoretically argue to you what you're really seeing is the object vibrating gravity. It's not making photons. It's taking the energy that's hitting it already and compressing it in space and turning it into higher frequency photons. But I mean, it's kind of a complex subject. The universe is full of energy. Some percentage of that energy is in the form of what we call a photon, a pattern. Some percentage is in the form of magnetism, in terms of another pattern. They're just patterns. Magnets don't make magnetism. All a magnet does is take the universe that's hitting it and reflect it, okay, with a pattern. Red, blue, you could argue. It takes purple light. Purple comes in, okay, in the form of little red and blues all randomized. And what the magnet basically does is push red this way and push blue that way, you could argue. The simplest description. It's more complicated. It has to do with a bullseye pattern and all this shit. But I'm just saying, it changes the pattern. So now another magnet can see the pattern. Another dipole can see the difference between the red side and the blue side. It can see the blue radiating more blue, and it can see the red radiating more red. Even though it's exactly the same energy that went in, it's clearly changed it in the sense of how it will affect something because it's been segregated into a pattern. All right. But they explain so much. I mean, my whole life I was wondering, well, how could there be energy inside of a magnet? It can't be energy in there. There can't be motors. There can't be something making magnetism. And it just occurred to me a couple of years ago, oh, it's so obvious. It isn't doing anything but changing how it reflects the energy that's hitting it. And that's all we do, and that's all the earth does, and that's all everything does, is just reflect what goes in. Let's see, that's why I wouldn't even put it in a science subject. Okay, so you're still talking about the cosmological stuff is not very physics. Again, I'll say it again. I've said it before. But another one of those little key facts, key ideas. The idea is that, oh shit, as soon as I said it, I said, oh fuck, yeah, that's so fucking important. The small universe, the one where the electrons and protons are in, the space they're in, that's the real universe. The rest of it is all just pictures. It's all just holograms, so to speak. It's all just patterns in that universe. That universe does everything first. And it does everything in insane volumes. So in 1 minute of our time, or 1 second of our time, it's like 1 billion years in their time. They have done 1 billion years of interactions in 1 second of our existence. That universe is so much smaller and so much faster. And that's the one you have to understand if you're going to understand what's happening in this universe of big things. Because that little universe is making this universe. We're an emergent byproduct of the small universe. It's not the other way around. The small universe doesn't do what the big universe says. The big universe does what the small universe says. Huge conceptual idea. As big as evolution versus God theory. Just it's a huge conceptual difference than what conventional physics teaches. I mean, every one of your heartbeats is the byproduct of 1 billion, 1 trillion, 1 gazillion individual events. Individual atoms being ionized. I mean, an insane number of events in just 1 heartbeat. Alright, 2-minute warning again. You've all fallen asleep or something. 9 viewers, not very good, frankly. You really would think that there'd be more people interested in physics, as a conversation. But no, not so much. But whatever. I mean, I wish there was somebody else doing this. And there isn't anyone else doing this. Because I'd watch it. I'd watch somebody explaining. Great stuff. Can you give the conventional physics view of this concept? What concept? The concept of the small universe? You want me to draw the small universe? Can you give the conventional physics view of this concept? I don't know what concept you mean. Have you had 50 views? No. Viewers, no. I think I hit 30 one day. Um, um, so the concept of what? Come on, you can tell me. I'm just not following along with what concept you mean. The conventional physics view of this concept. I'm just saying they teach physics as if there's different, like the big universe is different than the little universe, that the combined atoms are functioning, like magnetism is different. Big magnet is somehow different than the little tiny magnets that are the atoms that are making the big magnet. You know, that kind of stuff. They create a huge separation. The big concept that small things rule the big world. Yeah, I'm just saying that they never say explicitly, okay, there is no, like, space tells matter what to do kind of thing. When they say things like that, they don't say it on the scale of the right universe. They imply that space tells planets what to do. It doesn't tell planets what to do. It tells atoms what to do. Atoms are affected by gravity. Earths aren't. I can put one single atom right next to the Earth, and it'll move exactly in the same orbit. It'll do exactly what the Earth does. It's the atoms that are being controlled by gravity. It's not the Earth. The Earth isn't being controlled by gravity. The individual atoms are being controlled by gravity. I mean, it's that kind of way it needs to be viewed. Now, obviously, when you have a whole condensate of a bunch of atoms, the individual atoms are protected from the outside world, and they're communicated by electricity. They communicate force by the force between them. They push on each other's forces that are trapped inside. But it's still the same idea that all of those interactions have to take place before the big object moves or blows up or does anything. Nothing in the big universe does anything until all these little things do it first. And they don't say that. They talk like as if, the sun is making gravity. No, the atoms that are the sun are creating gravity. The atoms are doing it. The electrons and protons are doing it. That's the huge conceptual difference. Everything is a force and matter. Everything about force and matter is really about force and electrons and protons. I mean, I could show the simulation again, but you know what I mean. That's all there is. All that little stuff has to move around before anything big moves around. I notice your simulation shows electrons and protons as the same volume size. Well, that's because they have to have the same charge. So charge is your profile to the world. Charge has to be equal. So they can't have equal charges, unless they're probably the same volume. Now, their density can be different. So one can be heavier than the other, but they can't be a different size, or then the two poles of the magnet wouldn't be equal. There'd be no symmetry in charge. Charge wouldn't have any symmetry if the visibility of protons wasn't the same as the visibility of the electron. So the argument I would make is yes, protons are heavier. That is, they're the same size, but they're denser. They don't move as fast, simply put. So they move 10% or 50% slower, which means that's why they get trapped in nucleuses, is because they don't move well. And electrons do, so they end up being on the outside. The stuff on the outside is more mobile. All right. physics is an interesting subject, but some of the math, especially the false theories, make it hard to get into for some people, I think. Yes, yes. I mean, so clearly it could be taught as all experiments and visually and with metaphors and simulations, and you wouldn't need any math at all beyond the math of geometry, right? I mean, you could just do some of the simple geometry, Pythagorean kind of ideas, little tricks to be able to make a shortcut of approximating the size of things or understanding its motion over time. But you really don't need to do all of the extensive math that they have created. You don't need to do the, Einstein tensor bullshit. I first would argue it's bad theory. It doesn't even get right answers. The Schrodinger wave equation is a great example. It's not really an equation. It's an equation made of numerous other equations. So it's not even a mathematical equation. It's a description of a mathematical process. And the process is circular. If I know everything, I can know everything. I mean, that's almost what it's saying. It's saying something that's stupid. If I know where everything is now, I can know where everything will be tomorrow. Yeah, you can. But you can't know where everything is, so why are you even bothering with it? It's a silly, never applicable equation. All right. People seem to get tricked by ideas of free without explaining how that makes sense. Well, free is a silly word. Free is a white space word. Right? So it's a placeholder for an opposite to imprisonment, confinement. That's all it is. It's saying, well, what is non-confinement? Well, that's free. Okay, but what is it? Okay, it doesn't mean anything because you have to define first the confinement. Right? So without the confinement, without the black on the white paper doesn't mean anything. So if you don't first have an issue of confinement, you don't have a reason to say free. Because everything's free then. Unimpeded, unrestrained, unconfined. And that is impossible. Because some things are always confined. Some things are either force or they're matter or they're round or they're square or they're triangle. Some things are always something. They're not everything. They're already confined to being that thing or that thing or that thing. They can't be everything. So they can't be free. Let's see. I will be going to bed soon. Well, I mean, you can give us all your reports. You're going to scrub your feet first and do this and do that. I mean, you give us all these reports. But anyway, I will be waiting to see Brozo's new experiment. Yes, it will be interesting to see because he's going to pretty much overtly attempt to force an experiment to produce the result he wants. That's what we'll witness. He's going to take an experiment that was theoretically not bad, and he's going to break it, to force it to come out the way he wants it to. Well, I don't even know why I would bother even saying, yes, hopefully Brozo gives us an honest experiment. It's not going to happen. He has no intention of showing you the truth being revealed. That's why he's done all kinds of experiments that he never showed anyone, is because they didn't confirm what he wants to establish the truth to be. I'm just saying, there's no way, if he would just diagram a lever, he could already, show us he can be honest. But he won't do it, because he can't honestly explain how it works. Honesty is what, all the videos he's not making are the ones where You'd have to be honest to make them. That's why we don't see them. That's why he doesn't respond to anything, is because that would require him to be honest. And he has no intention of being honest. He's a propagandist for a silly religious theory. And that's it. And he's only doing it because I am a Muslim or something, and he's a Christian or some kind of thing. He doesn't even believe in God, but he knows he dislikes Muslims, so he'll fight the evil Muslim. Oakley Doke, losing some of our viewers. Yeah, too bad. But yes, whatever. Good night. Blah blah blah. Sorry, I'm just not much of a pleasantry person. I guess it's just part of me just refusing to admit, how frustrating life is, where you can't control anything, you can't really do anything for anybody. I mean, oh, I hope you have a good day. I mean, it's just so lame. I mean, my hoping isn't going to help anything. It's just so weak a thing to do that I just can't do pleasantries. I mean, I can say hello when somebody goes by on the street or something. Well, it's just, yuck. You plan to post any new art on your website? Yeah, well, when I do so, maybe. Well, yeah, I'm going to see if I can collect some more stuff and do some more things that are more interesting. But yes, I'm just so much to do, so few me's to do it. Kind of problem. Yeah. I just have way too many things to manage in my little crappy life. And, it takes a lot of work thinking, always thinking. A lot of work thinking. Alright, 2-minute warning again. Yeah, so let's see if it works this time. See if it sticks. And such. So that is what I miss about Hothaday. At least Hothaday would engage in some of these conversations. And, he'd spend an hour, explaining his point of view and making some arguments. And so at least that was something, And all the rest are so lame. They won't touch the theoretical arguments. I mean, it's like you could make the argument about photons, in Einstein's theory that they're bent twice as much by gravity. And you could just, you make the simple point that there's no example of any other force, that is anything going the speed of light, being bent by gravity. So electricity can't be bent by it, magnetism can't be bent by it at all, let alone twice as much. And you're just saying, why the exception for photons? And twice as much. I mean, it's just so crazy an idea when you think about it. I mean, twice as much as an electron, twice as much as some other thing, some material thing. Somehow light, the fastest thing in the universe, is bent twice as much. I mean, it just seems, what's the theory behind that? especially if you sort of recognize that all the stuff moving the speed of light must be made out of the same stuff. If you use that logic or apply that logic, that it would seem a bizarre coincidence that all these different things move exactly the same speed, and that gravity itself is moving the same speed as a force. And there's all this evidence that forces don't interact with forces, that I can't bang photons into photons. How can I bang gravity into photons? Yeah. And so with that context, you would say, shouldn't they produce hard evidence? If they're going to argue that it is bent and that it's bent twice as much, shouldn't the evidence be pretty hard? Because they're going against a pretty strong circumstantial pile of evidence that says it doesn't make much sense. Why the exception to the rule? Exceptions to the rule should be extra evidence. When something's an exception to a rule, there should be extra evidence, not less evidence. And mv squared is kind of an exception to the rule. It should come with extra evidence, not less evidence. Alright, well, I guess we'll head off. So, till the next time and such and so forth and whatnot. This has been a draftphysics.com and debatephysics.com video presentation. I'm James Mason. I'm dead and such. Something like that. Anyway, until the next time. I'm tired is what I am, I guess. Yes, that's what I am. I'm tired. Yeah, it's late. I'm tired. That's the explanation. Alright, so, till next time, and such, and so